Hi guys, in this video we're going to go over Einstein's theory of special relativity. So that's where that equation came from there, E equals mc squared. So E stands for energy, equals the mass times C, C stands for your speed of light. So your speed of light is always 3 times 10 to the power of 8, and you just want to make sure you learn that number off, but it's also on your data sheet if you need to look at it. So what we're doing here is going to find out the change in mass when a helium nucleus is formed and how the energy released for fusion. So we can see here is that when the helium is formed, what we're going to do here is that we're going to have a helium nucleus. We know a helium nucleus, you just need to learn this off, is remember a helium nucleus is an alpha particle 4-2. So we need to learn that, and you know that in a helium nucleus, we have those 2 protons and 4 take away 2 gives me 2 neutrons. So when that helium nucleus was formed, I needed 2 protons to join with 2 neutrons to make my helium-4 nucleus. Okay? So I'm going to figure out what is the change in mass when that helium gets formed. So we know this is fusion. So fusion is when I have my 2 lighter nuclei that join together to get my heavier nucleus. And the reason why it happens is because the combined mass here, when we join the mass together, the combined mass of the nuclei of the fusion products is always bigger than the mass of the fusion product, okay? So what then happens is the change in mass, the difference in the mass then comes out as energy, and that's where we get energy then when these nuclei get formed. So I'm gonna figure out what that change in energy is when the helium is formed. So I've got 2 protons, it tells me the mass of my proton, so I've got 2 times 1.673 times 10 to the negative 27. And I have 2 times 1.675 times 10 to the minus 27. That is the mass of my neutron. Okay? Then I know the mass of the helium. It told me my mass of my helium up here. So I'm going to find the combined mass of my 2 protons and my 2 neutrons. So again, what we're doing is 2 times 1.673 times 10 to the negative 27, and we're adding 2 times 1.675 times 10 to the negative 27. So the combined mass there of my 2 protons and my 2 neutrons is going to be 6.696 times 10 to minus 27. And you can clearly see this number is bigger than the mass of that fusion product. So to find what the change in mass is, all we're going to do is take the mass here and subtract it from the mass here. So what I'm going to do now is the mass here, and we're going to take away that mass. So we're going to take away 6.648 times 10 to the negative 27. Figure out our change in mass there is 4.8 times 10 to minus 29 kilograms. And again, that makes sense, right? We know that when these 2 protons, these 2 neutrons join together to make that helium nucleus, there's going to be a loss in mass, right? And that change in mass is what comes out as energy. And we can even calculate what that energy is, because all we do is we take our mass and we multiply by the speed of light squared. So you take that mass and you multiply by 3 times 10 to the power of 8 squared, you'll get your total energy there to come out as 4.32 times 10 to the negative 12 joules, okay? So another example could be, what if I've got a carbon-13 and we're joining it with a proton to make a nitrogen-14? I want to figure out the energy released in the fusion. So again, we're taking our 2 lighter nuclei, we're joining together to make a heavier nucleus, but the combined mass of the nuclei that join together is less than the mass of the fusion product. And that change in mass then is what my energy is released. This time it's different. This time they give you the numbers in U, okay? So what U stands for is an atomic mass unit. So you can either go to your data sheet and look up what an atomic mass unit is, what that number is. And if I went to my data sheet, so hopefully you guys have your data sheets on your phones just because it's handy. That's why I always have mine on my phone. Or even better, you have it printed, right? Because you want to make sure that you've got it printed so you have easy access to it. And clearly I don't have easy access because I can't find my data sheet now. Oh, there it is, my bad. So AQA data sheet, if I look up what a U is, it tells me 1 U is equal to 1.661 times 10 to the minus 27, right? So it tells what a U is. So either I can multiply this number by that number to find out what that is in kilograms, and then we do the same way here where we subtract the kilograms, Or because it said energy, you can also see in your data sheet that it tells you what 1U is. So it tells you that 1U is equal to 931.5 mega electron volts. Okay, so it tells you what 1U is. So remember, an electron volt is just another way of saying energy. So I could do that way instead to make my life just quicker. So again, one way is you can convert it all into kilograms using this number, and you do the same step as before, find the change in the kilograms. And once you find the change in mass in kilograms, then you do E equals mc squared to get it into an energy. Or because they give it to U, which is nicer, and we know what 1U is in energy. So I can then figure out, first of all, what the change in mass is. So the change in mass is my carbon and my proton. So I'm going to do my 13.00007U. I'm going to add my 1.00728U to see what that total mass is before. So 13.00007U, add 1.00728. U is going to give me 14.00735U. And then again, hopefully you can see the combined mass is bigger than the mass of that product formed. So I'm going to find the difference in these two numbers. So I'm going to subtract these two numbers to find out what my change in mass is. So now I'm going to take away 13.99925 to find what the change in mass is. I get a change in mass of 8.1 times 10 to the minus 3U. So that's my change in mass. So again, what I can do is I can put that into kilograms by multiplying this number, do E equals mc squared. Or because I know that 1U is equal to 931.5 mega electron volts, I can multiply this number by 931.5 mega electron volts to get what that change in energy is now in mega electron volts. So if I multiply by 931.5, I'm going to get a number there of 7.55 mega electron volts. And that is a fine unit for energy. But if you want to put it into joules, you know, you can just, mega is times 10 to the power 6. And then to get electron volts into joules, we just multiply by 1.6 times 10 to the negative 19. But again, you can leave energy in electron volts because we normally do. So you just check out your answer line to see if they want your final answer in joules or if they want your final answer in mega electron volts.